Hello everyone. In this video, we shall learn about sound and its properties. Couldn't hear that, right? That's how important sound is. In this video, we shall learn about sound and its properties. Do you know that animals underwater speak and communicate? Whales and fishes speak amongst themselves in their own language, just as us. It's interesting to see how sound can impact our lives. If there were no sound, we would not be able to communicate. Language would not be there. Audio systems where you hear sound would not make sense. And you would miss out on the music, the sound, the noise, and only silence would prevail. The topics to be covered under the topic of sound are: in previous videos, we discussed sound as a form of energy. That when energy is transferred from one form to another, one of the forms of energy it can be converted to is sound. When we press a doorbell, electric energy is converted to sound energy as the bell sounds. When we start a speaker, the movement of the speaker's membrane produces a sound. So sound can be produced and transmitted. Sound energy travels through water, metals, and all kinds of objects. It also travels through flesh and bones of human beings. As long as there is matter, sound can travel. Sound is transmitted as a wave. A visual representation of sound waves shows that a single molecule of air moves back and forth while sound is produced. This oscillation creates a sinusoidal curve, showing the displacement of the molecule back and forth. It is interesting to note here that sound creates a wave of particles in oscillation until it reaches the eardrums, so that the same vibration is produced in our ears and we can hear sound. So, as the example illustrates, sound is a form of energy that is transmitted through waves. These waves are created by oscillating air molecules that vibrate in points of time. Sound can travel through any object as long as there are particles. If a space is void, without atoms or molecules, sound waves cannot be transmitted. If it is a solid, sound waves can be transmitted faster as molecules are tightly placed between one another. The important takeaway from this is that sound needs a medium to travel. When the sound waves travel, we see the atoms moving back and forth. The maximum displacement from the equilibrium position is called amplitude. Be careful that you do not consider the full length of displacement as the amplitude. Another important concept is that period is referred to as the time that a particle takes to fully move back and forth once. Period is measured in seconds and is called a cycle and is represented by the capital letter T. If the period is shortened, that is, time required to oscillate back and forth is reduced, the pitch of the sound increases and we hear a higher note. Under normal circumstances, speed of sound is ideally a value of 343 meters per second. This value may change if density of air increases or decreases depending upon the medium through which it travels. Speed of sound is not the speed of the movement of particles. It is the disturbance created by the oscillations of the medium's particles that are in a straight line motion. Sound is a longitudinal wave. We know that speed is equal to distance divided by time. In case of sound, it would be the wavelength of sound over one period. Here, the Greek letter lambda represents the wavelength of sound and time is the time period. Since frequency is given by 1 over time period, speed of sound may be defined as lambda times frequency. Be careful. Do not interpret this formula by thinking that speed can be increased by increasing the frequency. That does not happen. If you increase the frequency, the wavelength will decrease by the same factor, keeping the speed constant. In fact, there is nothing that can be done to the speaker to increase the speed of sound. So, how can we change the speed of sound? The only way to change the speed of sound is to change the medium of transmission. So, for transmissions within air, the temperature of the air can be changed along with the humidity or the density of the air. Or air can be totally replaced with another material like water, helium, metal, or something else. People have the misconception that just changing the amplitude of sound may change the speed of sound. But that also does not happen. Sound may be louder, but speed of sound does not change in the same medium. In other words, making a bigger sound won't cause anyone to hear you faster. Differences in amplitude of sound can be shown like this. Loudness is a measure of the sound energy reaching the ear per second and is shown by the differences in amplitude. Frequency differences cause high pitch and low pitch with the same amplitude. The faster the vibration of the source, the higher is the frequency and higher is the pitch. It represents how shrill or bass the sound is. This brings us to the end of the first session on sound. The important concepts that we discussed are here for you to revise. We will see you soon with another lesson from Notebook. Until then, goodbye.